So just for a quick second, why don't we do an introduction on your experience and why you are a qualified participant in this panel. Paul?
Sure. Okay. So my name is Paul Bates. I'm with ASTM, as Shannon mentioned. I've been in additive for 24 years almost now, doing a lot of polymers, and then more recently in the last 10 years or so in metals, doing instruction on the use of the technology, safety audits, and safety courses on it, and just pretty much exposed to most of the materials and most of the practices using this technology.
A quick intro from you as well.
Thank you, Shannon. Matt Donovan. I don't know what to do on that.
We do metal printing, not microphones.
Yes, we do metal printing, not microphones. I've been in additive for about 15, 16 years. I've mostly done powder bed fusion, but a lot of DED and polymer printed electronics and other fields. So I've kind of been all around the block, and I've made a lot of parts, slung a lot of powder, fired a lot of lasers.
Great. So we're going to start, I think, with the safety, because I think if you're investigating bringing in metals, a very cognizant first step would be to recognize the safety of your people, because while printing in metal is very important and very lucrative and allows you some great engineering wins, protecting your people is ultimately that much more important. So does anybody have metal in-house just yet? I know you do, Ryan. Okay, and of course, machine manufacturer right there. So Paul, if we have somebody looking to investigating incorporating metal into their own facility, outside of just shopping for a machine, so none of us represent an equipment manufacturer, so we're not here with an agenda to sell anything to you, but to create safety and quality for your operations, if that's where you tend to go. So let's talk operational safety initially. What if I'm coming in with the thought of buying a metal piece of equipment, what should I be thinking about for my facility to protect the occupants within it?
Well, I think there's a bunch of things you need to think about. It's not a simple identifying if the facility can manage a metals machine, but also what materials you're going to run, who are going to use them, what type of local codes and regulations may need to be evaluated. Depending on materials, you might have material storage restrictions to think about. But in the end, the most important thing is protecting your employees, because we all know your first job is to make sure that they're safe. And it's a law. So if you think you don't need to, you need to. If you don't think it's important, you're mistaken. It's highly important. Because you can make good parts, but if you lose two guys doing it, they're not great parts.
So not that I'm looking for a comprehensive list, but let's talk about kind of categorical operations as far as maybe PPE or drafting. Facility needs to just be considered. We're not looking to give them a playbook, but let's give them some ideas of just considerations. And there's companies and facilities that can create a playbook for that. But let's be a little bit generic on that.
Well, in the generic sense, think about it, right? We're trying to protect the employee, and that's our first goal. So they've got to have the right conditions to work in. So the facility itself needs to be built in such a way that it's well lit, it's clean, it's kept clean, that the equipment has been installed properly, and that the employees are protected using proper PPE, and not to cut back on your expenditure when it comes to PPE, because we all know if the employer is required to supply all of it. So if it's ESD safe footwear, the employer needs to have a way to make sure the employee gets that and has the proper footwear and it's maintained properly. The same with PPE, whether it's a PAPR respirator or maybe some of the face mask type protection. They've got to have the ones that fit right and have the right policies in place. Most manufacturers already have a respirator policy in place. If they don't, they need to create one and make sure it's put in place and it's followed. Safe operation, safe handling of the material, SOPs, right? Standard operating procedures. You got it for every other part of business, you need it for additive as well. And that means whether it's cleaning equipment, maintaining things, all that has to be prepared ahead of time. And those are some top level things to consider. Material storage, there's a lot of things to consider in doing this.
Oh, sorry.
Can I jump in real quick? one thing I would add to what Paul just touched on there is don't skimp on safety equipment. If you're an employer, if we're talking about safety, one of the things I really like about Jabil is it comes straight from our CEO top down. It says, we want to make sure everybody gets home safe, and they emphasize that heavily. But part of it's not just being safe, but don't do the bare minimum. Make it easy for people. Spend the extra money, buy good safety equipment, make it easy for them to use it, because you got to think like so I'm a manufacturing engineer at heart. You need to think like your employees do. If you make it onerous for them to put on their PPE every day, people start taking shortcuts. It's safer if you make it as easy for them as possible, give them as much choice as they can too, and get them involved in the process. Because by having your people involved with it and letting them know that you're doing this for their safety to keep us all safe, I can't emphasize that enough. So it's a personal soapbox of mine. Thanks.
As well it should be. And I think you're right. Things that we're a part of creating, we are more heavily invested in, just on anything, design as well. Let's talk about fire for a minute. So especially if you're in medical device and you're working with titanium, you're working with reactive metals. So let's just chat a little bit about fire prevention. What happens when there's a fire and you're working with reactive metals?
You need to recognize why there would be a fire, what's necessary to create this fire. We're working with these powdered materials if we're doing DMLS, and those powders, they have an opportunity to ignite under the right conditions. What are those conditions? Are we meeting those conditions, and when we shouldn't be? How do we avoid those conditions? So understanding what fire is, how it's created, and how you can manage it is really important. Reactive materials just are another stage above that, where they really like the idea of catching on fire. So you have to be more protective and more careful. And again, wearing the proper PPE. But you have to understand that eventually the chances are there could be a fire in your facility. So you have to go beyond to just reduce the risk of it, but also what happens if there is a fire? Do you have a plan? Do you have a procedure? Do you have training? Do your operators know what to do if there's a fire? Or do they just run around screaming and yelling? What's the plan? And you've got to have that in place, and you've got the right fire fighting equipment in place, and either local authorities need to be fully aware of what you have in your space so they know what to do, or if in case you empower your employees to manage a small fire on their own, are they trained to do it properly? Do they have the right equipment in place? And is it exactly what you're supposed to use, and not to have the wrong equipment in place when it's not suitable for metal fires?
Something I would add on to that. Frequently, I've witnessed this, and I know Paul has witnessed it a lot over the years, is people tend to buy equipment and then make the facility, try to retrofit things. I can't emphasize enough. Figure out what you want to do before you buy equipment, what product you want to make, what materials you're going to work with, what the needs are for that, and have a plan first, because so many people fail or they just incur so many after the fact expenses because they're buying equipment and then they're trying to make things conform to it. The better way to do it is know what you're trying to do your homework. Frankly, ideally get your facility suited for it, but some of that is at least do a preliminary DHA, dust hazard analysis, and working through that will really help you understand what your needs are before you get moving on that, because like Paul touched on a lot of these materials, they want to catch fire, and you need to be planning for these eventualities. So planning before you buy will save you so much time in the long run.
Matt, just to add to that, talking about doing the research, understand what your facility requirements are based on local code and requirements. Getting involved with the local AHJs, the fire marshal for your region, for your area, getting them involved early will save you a lot of hassle in the end. I've been to more than one site where they spent all the money, bought the machine, installed it, got it up and running, and then he said, we should probably call the fire marshal. It'd be good to chat with him. He came in and shut the system down, said you cannot run it, and basically said this is not allowed in our state, because that was the experience he had. Not a good answer. So know ahead of time, get that conversation going beforehand. Will save you a lot of hassle. If you're prepared, you have that safety plan, you have that equipment in place, or the plan to put it in place, he's going to be a lot more receptive than he would be if you cold call him at the end and say, sign this piece of paper so I can get started.
Just for clarity, because we're so used to using acronyms. We talk AHJ, authority having jurisdiction. For your fire marshal is who we're referring to. Just
Thank you. Acronyms, right?
Do
it. Yeah, we do.
Go through the library of words we know. I'm glad you did that because I actually was going to piggyback on you when you were talking about the notifying authorities, that there is some responsibility in your community when you're starting a facility. And if one doesn't know who they should contact, or if they contact their fire marshal and they have not yet had exposure to a metal 3D printing facility, what is there someone that they can call for some help on that? Is there somewhere they can go for gathering information to instigate a very healthy and conversation with authorities?
Well, there's so many different requirements and standards and rules that are in place right now that may or may not affect additive metals. It's a lot of research. And I know that UL created a facility standard document called UL 3400 that is a pretty good guiding document, and at least give you a good starting point at it, but it's not complete in the sense of it covers everything, but it does give you a good exposure to all the basic requirements to it. But there are some that aren't in there that are pretty important to know about too. You know, Matt mentioned about a dust hazard analysis. If you are looking at NFPA, the document, the 484 requirements for metal powder handling, it does require a dust hazard analysis for additive manufacturing. So it's something you definitely want to consider looking at. Another example would be I've lost my train of thought. I got so excited for a second. But definitely the research has been out there, but you're still reviewing those documents will get you kind of some guidance in that direction. But the fire marshal is going to need to be educated if they're not already, and that might fall on you. Bring them through, let them understand. I gave a tour to a site to a fire marshal who was a little uncomfortable with the process. And in the tour, I explained to him all the interlocks in the technologies, how it is inherently safe when it's operating if you follow all the rules. And he felt much better afterward, was much more willing to sign off on that installation than if he had just walked in there ice cold by himself and never had really been exposed to additive before.
Related note on talking to the fire marshal. Again, it helps if you have a plan before you go talk to your fire marshal. It helps if you've done your research, you've done your homework, and you know what you're intending to do, and you've at least, before you just go and bring them in, because there's a lot of information out there. There's a lot of hype, but there's also a lot of horror stories, and they don't, depending on where you land, and it's wildly different from county to county. That's one of the hidden issues with additive is depending on what jurisdiction you're in, you may be able to run aluminum, you may not. But it really helps before you go and talk to the fire marshal, because if they've heard a lot of bad horror stories about fires and explosions and things like that, if you have a well-prepared plan, you clearly know what you're talking about, and you show them, you present that you've done your homework and your safety first, safety-centric culture, that will go a long way to helping alleviate those concerns.
You did bring up aluminum. Good thing to know about aluminum too is there are other requirements that you may or may not be aware of. That aluminum material is considered a material that is the Homeland Security. Yeah, it's a material concern. It's basically the Homeland Security. It's one of those materials they want to keep track of, and you need to register with the Homeland Security if you're going to be handling or storing aluminum on site. If you're over 100 pounds, I believe, is the rule right now. And and I know all these machines, 100 pounds of aluminum barely fills it. So you're going to need to make sure you've got that in place too. It's not hard. They're not after you. They're not trying to make your life difficult. Yeah, what they really want is just make sure you have a plan in place for securing it, because it's not something you want out in the street. the crazy street we live on. So they just want to make sure it's secure. So that's a lot of what their auditing is making sure it's under lock and key. And what is your disaster plan? I know we use the word plan a lot. Get used to it. You got to have a lot of plans.
Before we shift kind of away from safety, not that we're ever away from it, because it's always a concern, but more into quality, is there any questions or things that we said that you'd like more information on? You've got some great resources up here. Anyone? We didn't touch on something that you're interested to know? All right, well, let's migrate. So interestingly, safety does migrate well into quality, because when you're filling out quality documents for your customers, you have to prove that you're safe and thorough and everything is documented, that your facility is operating as they expect it to, because they're going to invest in you, either building their parts if you're a contract manufacturer or if you're building your own. So there's a lot of leeway from safety into quality. Do you have examples specifically of what you've seen kind of safety feeding into the quality for you?
Let's see if I can boil that down. Trying to think of how to summarize. As Shannon and Paul know, I'm very poor at being succinct at times. Scattered is a good way to describe it, yes. The documentation is actually a really good, a good lead-in, because if you're doing an additive, I'm primarily an aerospace person, although I spend a lot of time in medical nowadays, and those are very similar as far as their requirements go. Documented everything that you're going to do, everything that you are doing, and you can't be shifting everything on the fly. You have to have pre-approved parameter sets. You need to have all your SOPs in place, all your training in place, because everything, unless you're just making widgets, if you're making something for a regulated industry, they're going to want full document traceability. We call it womb to tomb. So, in aerospace, I need to be able to demonstrate all the way back to the original nil lot chemistry of my part, all the way to traceability to the final part, everything we did throughout the process, and demonstrate it and be able to survive an audit for it. And we do that on everything, which is, that's just part of being aerospace. It's a little bit more exhaustive and additive.
Yeah, and I think aerospace and medical ride very much in harmony. They both have very rigorous regulatory agencies governing them. So if we're talking about standard operating procedures and work instructions, and traceability is very big in medical as well as aerospace. In fact, if you're looking at AS 9100 and ISO 13485 certifications, there's kind of a slimmer gap between the two of those. If you already have one, if you're a manufacturing facility that's doing it as a service, much like a Jabil, the gap from one to the other is a little bit more narrow. So when we're talking about SOPs, work instructions, there are software packages that allow that flow to happen, and there are proprietary packages within companies of their own, whatever works for what they've used in their quality department. Do you have experience on, if somebody is just creating this metal printing lab, on where to start as far as creating those very critical documents?
Well, that's a fair point, because my current shop, we're actually doing exactly that. So I've spent the last year and a half on my fifth go around setting up a 3D printing facility. So creating everything from scratch it's an exhaustive process. Where to start? One thing I guess for a starting spot, related to this, and this might not be exactly where Shannon wanted me to go, and feel free to corral me in, but the bit of advice I would give to anybody who's thinking about starting out in additive, after the whole planning, and you've got your plan in place and your facility plan in place, and you're getting ready to buy equipment, I would start with one machine and one material. Start with that and get all your pieces in place, because something is, as part of that plan is you need to identify all the pieces that you're going to have, and how you're going to manage that and how you're going to document these things. So things to understand is it's not just buying a machine. You can't just go buy a brand X, model M XXX, machine and park it on your shop floor, buy a bunch of build plates, buy some powder, and start slinging powder and making parts. I've seen that done, but then after you've done that, you can't do anything with those. So you need to understand there's a whole lot of upstream and downstream that you need to have in place as part of that process. So you need to be thinking of the upstream. So I talked about traceability a moment ago. You need some type of MES or ERP system to be able to understand and keep track of your powder, your feedstock, your plates, and the parts and all the CAD files in the infrastructure. The infrastructure is going to kill you. It's not easy, is the short version. It's definitely doable, but you need my emphasis to people would be is start small. Even if you want to buy 20 printers, start with one and build up on that, because you can probably scale it across. And I've witnessed in a past life that when you try to do too much at once, you generally don't get anything done. So my advice would be is pick a machine, pick a material, and get that all the way through the process, including the post-processing as well for these parts. So you need to be thinking not just your ERP and upstream systems, but your downstream systems. So you need to think of, how am I going to get these parts off the plate after I build them? Do I have a furnace to stress relieve these? Do I have a vendor that I can send these to that is 13485 capable, or AS9100 or NADCAP? Do I have a vendor that I can go to, or shop that I can go to get my parts cut off the plate with an EDM or a bandsaw, or am I going to do that myself? How am I going to process these materials? If I'm using titanium or aluminum, am I going to have inert gas grit blasting? Or if I'm doing medical parts, how am I going to get the powder out of these things, and how am I going to get them clean? How am I going to get all the powder out of them? How am I going to make sure that these are clean enough to put in a human body? That is an exhaustive process. So I'd start with, again, we're going to say the word plan all the time, is working through it. But, patience up front will save you a lot of time in the end, because so many shops, I know Paul and I have both seen it dozens of times, people buy equipment and then they're stopped either by the fire marshal or by safety or whatever. So if you start slow with the plan and map your process through how you're going to do it, it will save you time downstream.
Not only at a facility is that important, but the FDA is certainly, if you're doing products that are seeking 510K clearance, you've got a lot of paperwork to prove exactly those things. So traceability, in the event there's an unfortunate episode down the line, that's going to track all the way back again to the chemistry of the powder and your tracking system to show your involvement in that you did your due diligence to be appropriate following that work instruction and plan and the certifications that you've been given for that facility. Because the 510K rides on that, and the FDA shows up and does audits, and it's not fun when they give you a tick list of things that you need to either fully modify or make little tweaks to, because you don't want to lose your 510K for sloppy manufacturing for sure. Do you have anything to add to what Matt was just chatting about?
Well, I think Matt post-processing a little bit, and post-processing is a pretty important word. At a recent visit to an aerospace manufacturer, 70% of their time and effort is in post-processing. So you think, well, I'll just build parts on those build plates Matt discussed and cut them off with some saw or something, and that's all I need to worry about. That's not even remotely close to what you're going to worry about. The procedures and the methodology, just in the sense of medical too, the contamination, you just can't do it any which way you want. There's going to be a plan, and you got to document that plan. I have seen tremendous documentation in just the post-processing, removal of loose powder, how they process it, how they prove that they did it this way, how they documented all that. And it was really awesome to see it, because it can get really deep, and it's necessary. And it's maybe 70% of the process to do that.
Yes, so much more to add on that. The post-process is a big topic in metals. In addition, not only the process that's happening, but what other additives, material-wise additives, are used in that process? How is that going to impact the biocompatibility? If it's a medical device, how does it impact in aerospace as well? So yeah, they're definitely looking for that. What mediums are you using to tumble? What mediums are you using in your cleaning and passivation? How are you extracting the powder, for sure? Uh, Anybody have any questions? Kind of, again, we'll chat with each other, but we really want to make sure we're catering to you. No.
Is it better if I come down and make you ask questions?
Oh,
I can do that.
I see nervous chuckles. All right. Well, let's. Hey, Jason. Let's talk a little bit about the post-process. Well, no, let's do that later. Let's go in sequential. So when we're designing CAD parts within CAD to print, and we're talking about support structures, which kind of leads into post-processing, because if you do maniacal support structures, whoever your post-processing team is not going to love you if they're cutting brick buildings off of parts. So let's talk a little bit about support structures and being both effective yet not overly laborious when we're getting into quality, because where there's manual labor and support removal, that's where you can start impacting the model itself, where maybe they're buzzing off support structures from the down-facing surfaces and they jump up into the model itself, and now you're not matching CAD. So do you have any input on that? You're grinning, I know you do.
Oh, yes. Where to start with that? For one, well, yeah, part of the reason I'm grinning is I've spent a lot of time knocking supports off parts, and actually before even that, getting powder out of the parts. I've spent a lot of time with a hammer, and
quality tips for success. How's that?
First thing I would actually, just as a precursor to that, is understanding how you're going to create supports and how parts interact with support material. Something a lot of people don't understand is the fundamental function of supports. So when we're building parts in metal, and I apologize if I'm dumbing this down too much, right? So with referring to laser powder bed fusion or electron beam powder bed fusion, usually we have these support structures. They serve multiple functions. One is you can't just build parts out of thin air. You have to build them gradually. And if you're building a feature that, say, comes up and then over, you can't just build a shelf out in thin air, at least not on most systems. You need to have some type of anchor or support structure to get to it. But additionally, there's a huge amount of thermal stress in the laser powder bed process, and these parts are going to want to warp and pull and distort. So when you're engineering in your support structures, you need to do multiple iterations usually. There are some simulation software that will help you on that front, but frankly, if you're starting out, you need to just understand the physics of your process, and each material performs differently based on the amount of heat that you're putting in and how much heat you're putting in and where you're putting it. The parts are going to pull, they're going to distort, they want to yank away from the plate, which is why we do a stress relief operation before we remove them from the plate. If you just, for example, like a titanium part, I've seen some titanium lattice parts that people have built that if you don't do the stress relief, they literally shatter. And it's really fun to watch, but it can also be terrifying because, if you don't have your supports properly anchoring it down and you don't perform your thermal processes, this part that, it might be a $30,000, $40,000 part, and somebody nicks it with a support removal tool and it literally explodes on the plate. That's can be a bit intimidating for people. So supports serve multiple functions there. So then when you're doing these supports, you need to understand the physics of what you're doing, how the parts are going to perform. But then when you're designing your parts and designing your supports, you need to be thinking, can I get these off of the part? Can I get them out of the part? One of the things with additive, there's tons of hype about all of the crazy impossible shapes that we can make. And we've all done, or a lot of us have done some amazing parts in the past, but then the thing is like, that's great, I can create this impossible geometry in CAD and I can grow it, but then how do I actually achieve that geometry after I've built it and make it a usable shape? because I've made parts with heat exchangers that have crazy impossible internal features, but I couldn't get the powder out, or I couldn't get the supports off of them, or I couldn't support them to build because they would just disintegrate during the process. So it's a very involved and convoluted, and there's no one size fits all answer.
Right. I'm going to bridge that over. So you were talking about the software end being helpful because it's suggestive on support strategy. It's not always exactly what you need, but it is certainly a springboard to that. Moving into hardware, and you can help with this too, the hardware is starting to help us on quality mechanism with vision systems installed. And if we're shopping for hardware, again, we're not promoting any of the manufacturers, but just specifically what your experience is, where the hardware is starting to contribute to our quality dialing in or what's going wrong mid-build. Let's talk a little bit about that, how that's kind of aiding our quality efforts and moving us forward a little bit faster.
So if we're talking in quality hardware, I would put a huge emphasis on when you're this planning theme we're talking about. Part of that planning is, how am I going to qualify my parts? How am I going to inspect these parts? Because, if you're a conventional machine shop and you're used to, just CMMing every part or doing hard gauging for every part, and you suddenly start new additive, if you're really going to take advantage of the technology and the geometric and design freedom that it affords you, got bad news for you. Your conventional inspection equipment isn't going to really be very helpful. Like, some CMMs are more capable than others, but frankly, I can't emphasize enough the need for like some type of 3D scanner. If you can, a blue light scanner for dimensional inspection. If surface finish is important, white light scanning is very helpful, and those have different strengths and weaknesses. Related note, and the price tags start adding up really quickly. The dollar signs start rolling across. If you're doing critical infrastructure parts, aerospace, if safety critical parts, we typically CT scan a lot of parts depending on the criticality of the component, and that gets really expensive very, very quickly as well. But at bare minimum, I've seen some great scanning equipment here today so far, and there's all kinds of alternatives. That's part of knowing what the product you're trying to do, because that will drive how do you inspect it, right? Because if you're really driving the technology and trying to take advantage of every last little bit of mechanical advantage you can get out of additive, you're going to need some inspection equipment that will help you, as well as software, because frankly, there's some good software packages out there. And again, we're not trying to advertise for any one particular vendor, but buying a couple of those tools will go a long way to making life easier and helping you really truly take advantage of the process.
Oh, hi.
So the question was, besides scanning and software, for me, one of the challenges that's really holding AM back in medical is tolerances. Frankly, my experience is actually the machines are very capable on our tolerance-wise. At least the metal systems, we have machines that generally are holding tolerances in the 50 micron range. So that's pretty darn precise. And I'd say I'd take that 50 micron tolerance with a grain of salt, because one of our machine manufacturers cites that, and something to bear in mind when you're dealing with particle sizes that are, say, 20 to 63 microns. 50 microns seems a little bit, stack up wise, a little challenging, but realistically, we can easily hold under 200 microns. So I don't think it's necessarily the tolerances, but it's the interaction of all the processes and how they affect your part. Because yes, I can engineer a part, and I've made parts with walls that are down to 150 microns, but getting them to survive the process and being able to inspect that and hold that over long periods, because like depending on the process you're doing and what your build orientation, your support structure, your surface finish. There's a whole lot of factors that all pile on to really complicate the process. So, um, yes. So as he says, it's not the printer itself; it's the whole process. And it's. I don't know. I'm digressing. It's challenging, I guess.
Too, it's important to recognize that additive doesn't replace subtractive manufacturing. Subtractive is very much in harmony with additive. So a lot of implants that we're making require subtractive finishing at the end, exactly for what you're saying, to pull in those tighter tolerances on the 5-axis. But where the win becomes for them is, one, we might get the trabecular surface still on the implant. Maybe we're just, especially on a spinal planet, we're just machining the ends, right, for the smooth surface and dialing that in. But now you're not starting with a block of titanium, which one is expensive, and then there's all of the shards that are falling off. It's much more minimal because you're just honing in on that particular area. So a common thing we run into, especially when we're running into machine shops, is there's a mentality that we're trying to take away machining work, and we're not. We really just want to be a supplemental partner to that. So I definitely have seen things that still require the machining, and that's when you design for that, or maybe you're designing sacrificial tabs so as to have a holding point for the machine, and then they can zip it right off at the end. They're still working in tandem on a lot of those, but as he's talking about getting really tight tolerance and thin walls, that's in finding the right people or who can do that for you, who have had however many years of experience of failing, because we try to fail fast, right? Or dialing in your own team and allowing them to fail. If you don't have a palate for failure, metal printing is going to be really tough on your psyche, because there's some failing that happens. But certainly machining is really helpful in that space.
I think one thing I would mention, and Matt talked about orientation, when you talk about accuracy, repeatability, where it's positioned on the build plate is important. But one other thing to keep in mind is the number of parts on the build plate. It's surprising that you can maybe create one part, approve it, get everybody thrilled about it, and you can make one part on the plate over and over again. When someone says, well, can you fit 2 on a plate? That's a complete start over, because it changes some of those variables in the process. Just the time per layer has a massive effect on some of that accuracy and expectations the part's going to have in it. So it's interesting, all the variables that we have to manage and take care of. One change can completely change the output that you're going to get from the machine.
One point I touch on with that is I can't emphasize enough. You need patience. If you're gonna start doing additive, no, metals specifically, I suppose, but polymers are also challenging, and we've done both. So, a couple areas I would say on this front. First, frankly, if you're planning to install on machines and getting started in it, give your team just a year. Just plan on not having any revenue for a year. I know some people are going to start cringing and flinching and running away. I'm not saying you can't do it faster. Just plan on it, though. Give yourself a year. Give your team to get that one machine, that one material, the one product, and get it all the way through. Get all your SOPs, all the whole process robust. You can probably do it a lot faster. I've done it a lot faster, but if you plan on not having any revenue on that machine for a year, give your team all that time and give them the space to learn it and fail a lot and learn it in and out. You'll have a lot more success, because if you plan on, because I've heard more than one machine OEM tell you, well, we're going to drop the machine on your floor. It'll be there in 2 weeks. It'll take us a week to install it. We're going to train your team in a week, and you'll be up and running. You'll be making parts next month, and you'll be off to the races. And people fail. So don't. Give yourself that time. But then the other thing is there's the learning curve. There's a lot of learning. Frankly, additive, we talk about a lot of software. There's some great software packages out there that will help you anticipate things, but not to knock those software packages, but you know what? Half the time, in my experience, depending on what you're doing, and it always depends on the part. Everything always depends on your part geometry. It's half black art. It's half black magic and half science. and you need people to build up the experience and understanding of what's happening. And there's a learning curve. Some are shallower than others. It depends on the material you're doing. Some materials are much more forgiving. Some materials distort the hell out of everything. So, there's a learning curve. Just you need to be patient and be prepared. And the nice thing about the additive community, though, one thing I really love about our field is there's so many people here who are ready to help. People like myself, Paul, Shannon, and all of our colleagues. That's one thing I love is my competitors call me directly, and we share knowledge. So go do the research, talk to people, go to the trade shows, and learn about it, and don't be afraid to ask and fail.
Literally went where I was going to go after your conversation, which is find the user community. We're so much better together, right? Additive would be so small if we weren't talking and working together and building one another up. So finding your way into the additive user community is a great way to saddle up next to the people who have already sat in your shoes and want to help you, because the more successful you are, the more successful we are collectively, the better the machines get for us, the more materials that come out for us. So the wins are incrementally to all of our advantage, the more that we choose to work together and be good at building up the technology with one another. Let's talk about, wouldn't it be really nice if there were a committee or a business that had all of this standardized and we could just start from scratch? Like, I don't know. What do you think about that? A standards?
Well, again, we're not trying to sell anything. We're not trying to promote anything, but there are more than one, obviously, groups of organizations that do have standards out there. Know what they are. Get involved with those standards organizations too, right? Nothing is better than when you identify that there's a gap in standards that needs to be addressed. You can, shake your fist at the space and say, "Oh, I wish there was a standard." That won't get you real far. Join a standard organization. One I can think of is ASTM. Absolutely get involved and help create those standards. That's how it's done. So don't be shy or afraid of getting involved in it. Don't think you have nothing to offer because you do.
So the standards awareness and actual standards made. Actually, both of you are very heavily involved in standards for additive. What are the standards are growing all the time, right? More and more standards, material standards. I know that's a common question I'm fielding on where are we at on standardized materials for AM?
So, like I said earlier, I'm more of an aerospace person. Probably 60 to 70% aerospace and 30% medical or so nowadays. But so in the aerospace world, I live AMS, aerospace material specifications, have a number for everything. And when I started doing additive a while back, there was only one AMS 4999 back in the day. And there's now a few more, and there's a number of ASTM standards that really are good starting points for your materials. We've done a lot of work over the years. I want to say, as far as materials, I don't know the exact current number, but I want to say about a dozen materials. For example, F3001 for Ti 64 ELI is a good one that is very common, and a lot of product I make is to that standard. Yeah. Some of you might have heard of Ti 64.
Any questions to keep us going? No? Okay. When we're talking post-processing, because that's a big spot that's where the humans become involved often. We can do our lights out when we're building the parts, but once they come off of the machine, the safety of taking them out of the powder, because that titanium can ignite right now. Let's talk about that. Let's talk about getting the parts out of the vat and kind of the importance of being mindful with that from both quality and a safety perspective.
Well, at some point, you're going to be exposed to powder in its raw form, whether you're loading powder in the machine or taking a build out of the machine. And when you're exposed to powder, you have to be cognizant of the fact that there's risks to it. Inhalation, right? Everybody says, well, I'll wear a dust mask. I'll be fine. Is that enough? It's contact with skin. There's a lot of things that can put risk to you. my biggest suggestion is read the SDS sheets that come with the materials. They're a pretty good guide and they're required. So read them, understand them, and know what to do if you're exposed to these materials. But then going into post-processing, you've got to be able to take the parts out of the powder bed that they're in, remove the loose powder, and then start with the heat treatment cycle. And now you've got to move these parts around. You've got to get them into that oven and treat them with the heat to get the stress relief out, so they can be handled and removed from the plate in post-processing. But there's still powder in there. You're still exposed to powder. So even though you've got a part and you've cut it off the build plate and you give it to a machinist to do the final machining, is he aware that he's potentially being exposed to titanium powder, for example? Maybe he's very experienced with machining solid titanium billet, but he's never really worked much with powdered titanium. There's a risk of exposure there. Is he wearing a proper PPE? Does he know he needs to? Is that part of the procedure? That goes back to the plan you got to have in place. So, we talked a bit about the risks of the powder igniting. All those things can happen and have happened. We just want to make sure we minimize that risk so nobody has to worry about that in the future, dealing with it after the fact. Let's worry about it before the fact.
So let's stay on powder and talk a little bit about quality and how we preserve our powder so that we aren't building parts out of compromised powder, because our raw material is really key on this. So why don't you take that?
Sure. Absolutely 100% correct to touch on that, Shan. As a starting point, there are two major failure modes in laser powder bed fusion. At least where, if I had to say, 90% of defects and material problems occur: contaminated feedstock, or some problem with your processing system, where you actually melt the powder and turn it into a consolidated material. I've had some experience with some products with some customers that they muddy the process, but I will tell you, I can't emphasize enough. The process is where you're taking a very, very refined material, very, very precise quality requirements, and you're applying a very precise laser power in a very precise pattern to melt it and fuse it in your welding. And that's what your process is. So powder quality drives your process. So material handling is one of the most important things you can do, and understanding cleanliness everywhere and how you reprocess the powder, because titanium's going rate about $100 a pound, and when you only use say 2 or 3 pounds of it to build say a tray full of parts, and then you're loading 200 pounds of powder in to make 2 or 3 pounds of parts, you've got to reprocess 190 something pounds of titanium powder. That's very fine. It might be down to 10 microns. How do you get the agglomerate and the process contaminants out of it? How do you avoid contaminant with the soot from the process chamber? And how do you verify that the powder is still good? How do you maintain your quality? Moisture is killer, because most of these powders are massive desiccants. Aluminum in particular is challenging, because aluminum, you need to keep it below 50% humidity, relative humidity in your shop, because it'll absorb moisture if it gets too high. But you need to keep it above 30% relative humidity to prevent auto ignition. So there's both material handling and safety concerns with it, and then there's the storage and reprocessing of it. And frankly, also, not to put too fine a point on it, when you store it, where do you store it? How do you store it? What do you do for a fire extinguishing agent for that? So you need to be, these are all aware of. And as part of that whole planning process, before you go and just buy a whole bunch of powder and have it show up on your dock, you want to have, before you have, say, a ton of a reactive powder show up on your dock, and then your fire marshal happens to stop by, what are you going to do when he says, you can't have that here, and you've got $100,000 worth of powder sitting on your dock?
And Matt mentioned one thing as well, and I wanted to emphasize that. He mentioned soot or condensate. We've been talking about metal powder for a while, but there's one other material that's generated through the process that you now own and have to deal with. And it's called condensate or the soot. It's that smoky appearance as the laser is lasing on the powder. It creates this material, and it's collected by the system. There's inert gases that are flowing through the machines and it pulling into a filter, and you filter this condensate material out of the process, most of it. Now, what happens is you're now collecting this stuff and you own it. This is your material now. You are in charge of handling it. At some point, you're going to need to change that filter. That stuff is really, 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 really reactive. Forget about titanium, its reactivity, that's fine. This is way worse in the sense of if you don't handle it correctly, it will self-ignite, and it's guaranteed it will. So you need to handle it properly. Now, the filter systems that are out there today are getting better at keeping it in a safe form when you remove it from the machine to dispose of it, but you have to understand there are risks to it. So that material has to be disposed of properly and carefully and managed in such a way that nobody can get hurt by it. But know it's there and know you have to deal with it. It's not something that just disappears into the air. It's something you're going to have to manage and take care of.
There we go. So on that related note, just to keep on the material handling side, so powder cleanliness is key, and we can cover that a little bit more in just a second, but just to stick with where Paul was, I will tell you, actually, as far as on additive goes, the most dangerous part of the process is that condensate in the filters. Frankly, I know Paul and I have both handled literally tons of titanium and aluminum safely without any problem, pouring it into machines, sieving it, filtering it, all that. But the filters, that's actually the most dangerous part of the process. And you need to be aware of these things. And actually working with a hazmat disposal company, actually it's amazing with the additive processes. It's the little things that you don't think about. The actual additive process, designing and building parts, is actually, it's not as hard as the things we make the hardest are actually the most basic things like material handling, disposing of filters, handling build plates. It's actually, those are the things that are really going to trip you up when you're dealing with these. But I can't emphasize enough the condensate and how you're going to deal with the filters of a system that you're considering looking at. You need to, you cannot, right, yes, you can't, doesn't go out in the morning trash, but also you just cannot oversimplify it or gloss over that.
I think let's stay on materials for a quick second. This was a good, rich conversation. When we're talking about reclaimed material, so in the powder, there's some unsintered powder. How do you know when it's compromised? When do you stop using it? Or what's the testing mechanism for you?
That is a great question and a hot topic. For example, in aerospace, many people for many years claimed that, like, for certain safety critical parts, you could only use virgin powder, meaning powder that's not been used at all, and you can only use it for a part, and then after that, it's one and done, which of course dramatically increases the cost of your feedstock and the cost of your product. Nowadays, many of us reclaim powder. And there's the challenges of the material handling. One, I can't emphasize enough of having good, usually 316 or 300 series stainless canisters for handling and holding the powder and maintaining it under inert. So when you're reclaiming it, we always save it under an argon blanket, which serves a couple purposes. One, it helps keep it clean, cool, and dry, and it also helps moisture and contaminants from getting into it. But the other part of the planning process, depending on what product you're making, if you're working in a safety critical or regulated industry, powder quality, Shannon touched on it, is going to be key, because you're always going to have to prove, as part of that whole womb to tomb, how many times have I used this powder? Did I verify its integrity after it was reused, or after how many reuses? Do I have traceability throughout the process? Where did this powder come from? Some people blend powder, and that's a big sticky topic. And the short version I would emphasize with that, and I'm happy to talk at length afterwards as well, is there's many different ways of tackling that, but maintaining your traceability of where the powder went, what it was used on, what builds it was used on, and how you reprocess it and recertified it. So some of the things to think about when you're looking at your equipment is how am I going to check the powder, not just mechanically sieving it to remove agglomerate, but how am I going to verify my PSD, my powder size distribution? We've talked about, these fine particles. It's pretty typical in titanium, for example, to use powder that's 20 to 63 microns in size, and not just running it through a 75 micron sieve is not all going to be just sufficient. You need to verify that you're not picking up moisture, verify that you're not picking up contaminant, that your powder size distribution is not skewing towards fines. So there's a lot of ancillary equipment that is very beneficial, and having a good robust process to how you reprocess it is very helpful. The last thing I'll touch on, and before I hand off, is on this one is the best way to manage that, just good housekeeping, good processes, and minimize the amount that you handle the powder.
Another good thing with that is density cubes and dog bones or tensile bars on your build, so that if you have to break into the powder somewhere down the road, you've captured it in an unsintered cube. So building your little sacrificial parts and tucking them away through your system and your plan that you've made is good. So we're winding down on the last few minutes, and we want to make sure again that we're covering whatever questions. We're actually all together again at 4:30, I think, this afternoon, with not really any topic. We're just going to chat with you or chat with each other if you don't come. But we'd love to touch on more points outside of quality and safety with you, or more on quality and safety if you're walking around today and you think of something you didn't, either we didn't express or you didn't get a chance to ask. So we'd love to see you again at 4:30. But anything else, so that we're clearing the stage for the next one, that we can be closing out with from you? I hope we were informative. We had fun. We like to be together and talk about additive.
I think one thing too to close this out too is we've talked a lot about different subjects, whether it's safety and quality and just in basic additive manufacturing topics. Just know there's training out there that's available from a variety of sources. Some is pretty, kind of focused on maybe design or some other aspects, but there's also training that really encompasses all the things we've talked about. Do some research, find those training programs that are out there. Reach out to me, I can guide you to a bunch of them that are really good, really inclusive training that covers a lot of testing, a lot of all the detailed stuff that you're going to need to know at some point. It's out there, it's available, and to take advantage of it.
The investment, indeed. And the trade shows will have that, like Rapid and AMUG are two of the big additive shows, and they do supplemental training, often with a cost, but you're already at the show anyway, so then you don't have the logistics to add to that. But yeah, definitely the resources and the investment on getting qualified training is important.
I guess one thought I would leave you with is there's a lot of hype, and there's pretty broad spectrum of message you might get from this. You can hear from some sides that may oversimplify it, make it sound very easy, and then there's an awful lot of doomsaying on the other side of, well, how can I work with this material? It's going to catch fire, I'm going to blow it up, and I'm going to kill all my staff. It's more in the middle. What I would tell you is it's really not that bad. Patience just taking your time, doing your homework. It really is an amazing process, and I've been doing it for 15 or so years, and I love what I do. And it's not that hard if you just take the time to do the homework and do the research, work with the resources that are there, and there's lots available, and you can really have some good success with just patience.
Thanks again for joining us. I hope to see you a little bit later or catch us around. We're all here for the day. Take care.